Okay, we get to the most important phase in Node.js, and there's the poll phase. This is where I/O are actually being executed, and this is also where I/Os are being I/O callbacks are being executed. So what is the difference between these two? So we have let's go through them real quick. The initial phase, that's when the first piece of code before the event loop gets executed. Then we jump to the timers. There are the timers, we run through them. Then the pending callbacks, these are the TCP errors. And then we have the idle prepare stage, which we talked about. This is an internal stage just for Node, and we did show that prepare actually does something that it is visible to us, at least if we do the system calls, and we can peek at Node and see what it is doing behind the scenes. Now we've seen that some setup is happening, preparing for what? For this puppy, the most important phase, for the poll phase. Let's jump into it. So two things happen in this poll phase. So the first thing, our I/O is being polled. And polling, if you don't know, is almost like a querying to find if there is something or not. You poll for something and you wait. Essentially, that's the gist of it. An example of I/O that is being polled, I/O that is being executed here is you're listening on a socket. I'm binding this socket on port 8080. That's an I/O that is being pulled. Okay, and that event, that system call that we execute, that is in itself is an I/O being executed, right? A read and write through connections. As I receive connections from on this listening socket, I create these connections on the server. I can read and write to connection, and these in itself are also I/O polls. Because if you ask the kernel, the Linux kernel or the operating system, hey, I have this connection, I want you to tell me if there is something on those connection, right? So essentially, if you think about it, it's like a socket, right? And this is the listening socket, and let's say this is 80. Terrible handwriting because I'm using the trackpad. But if someone is connecting, once someone is connected, right? Oh, I'm actually covering that thing so I can go on screen. Yeah. But yeah, if someone is connected from the client side, then what we get is actually a connection object, right? And this connection object, right, will also have a unique identifier. This will have some unique identifier. Let's see, I don't know, 20 file descriptor, they are called in Linux. And when you accept a connection on the socket, you get another file descriptor, let's say 21, right? An integer file. And if you accept another connection, you get another one, right? 22, and so on. And this uniquely identifies the connection using the source port, the source IP, destination port, destination IP. And this data comes in here, and then data goes out of these connections, right? Because then each of them will go to a completely different client, of course. So what we do is we poll for I/O, asking, hey, kernel, give me any data on this connection and give me any data on this connection. And that's essentially what we're doing with polling. So reading and writing connection is what we're doing. Polling, we're polling for data. When we poll the socket, that are actually listening socket, what we poll are actually, we're polling for connections, right? It's like, are there incoming connection to accept in order to call actually accepting a connection in order to produce these puppies, the actual connection objects, right? Connection file descriptors. Yeah? And the other beast, right? So all of these are networking, right? So the other beast is is actually reading and writing from files, which is a completely different beast. You know, files, reading and writing to files are also being, not really being polled per se, but you're just sending a request to read from disk, right? Like you have, this is the disk, and you say, hey, I want to read, and this is a system call, right? Or I want to write, and that's another system call, right? You can read and write to file, and that takes finite amount of time, right? So this is all the IOs that being done. And the other part of this equation is when the event happens, when the read is successful, you already executed the read. So there is the time where you're executing the read or the write. There is a time where you're executing the read on the connection or the write on to the connection. There is a time where you actually listen, right, on a socket. And then there is the time when that is successfully completed. When that's successfully completed, you can register a callback saying, hey, on read, please call this function. On connect, please call this function. On listen, please call this function. Yeah. So essentially, that is what we're talking about here when we're talking about I/O, right? And so that's very critical to understand these, and it's gonna become clear as we go through the course. So don't worry about it. So slowly, we're gonna go through this tons of times. It's not like we're gonna talk about this and forget about it. No, this is gonna come over and over and over again until the last breath of this course. Also, one note here is like, if you ever heard of dynamic imports, these import instead of require, these are also executed in the poll phase, right? So import are asynchronous, i.e. they are delayed until the poll phase, and they are read. You're reading their file just like reading any other file. So they are considered an I/O, which then followed by a parser to parse the module and doing all that stuff. Okay, let's talk about blocking. So blocking, Node will in fact block in the poll phase. Like especially like if you're doing, let's talk about like normal blocking, right? Where we're talking about, say, let's pull up the pen again here. Like say here we have a disk SSD and I'm doing a read, right? And I said, hey, read file. And whether I'm talking about both read file sync and read file, which is the async version, right? It's slightly a little bit different. We'll come to that, but I'm talking about the asynchronous version where it goes into the poll phase here. If I'm reading the file, in this particular case, that read, so there will be a system call here that's called read that will be fired to the disk, and that will take a finite amount of time, of course, right? But it's supposed to be a clock watch, but yeah, so it will take a finite amount of time, and in that time, Node will block, right? Because especially read files, like operation, like read file operations are always almost blocking, right? The only exception is IOU ring, which is still, it is blocking, but another kernel thread is doing the blocking. But yeah, so I'm doing that. So meanwhile, if you're in the poll phase and you're calling read, that's it. You're blocked. And now how long you're blocked is the question. If you're reading and you're reading 2 gigs of file, then you'll be blocked for however many millisecond will take until you bring that up. And the other approach is, the other problem is when you have connections, right? If you have actual connection object and you're calling read on the connection, right? What we're doing with the read on the connection, these are also blocking. So with and this is a really complex topic. That's why I really hope you watch my operating system course, because I talk about this in details. The art of asynchronous I/O comes from this. But in a nutshell, read and write operations are blocking. Right? So asynchronous I/O was designed in the Linux kernel and other operating systems to allow to be non-blocking. How? EPOL is one approach, and this is what we're going to talk about here in this course, mainly. EPOL is a way to take an array of file descriptors. Hey, here's a bunch of connections. Tell me if any of these guys are ready. And I'm gonna wait. And instead of calling read on a connection and there is nothing, because if you call read on a connection, unlike file, if you call read on a file and you're gonna be blocked, but only for finite amount of time until the operation is complete. If you call read on a connection, right, this is a connection object, unfortunately, if there is no data that has been sent by the client of this connection, right, then that read will block forever. It's a blocking operation. And that's the danger here. And that's why we need things like EPOL or KQ or other the asynchronous approach that says, hey, here's a file descriptor number 22. Here's a file descriptor number 23. Please tell me, kernel, when they are ready, just notify me. So what you do is you call this function called EPOL wait, another blocking operation. So what we do is play a game. We delay these waitings until the end, right? So we say, hey, here's an array of connections. Just tell me when any of them are ready. And by ready means there are data that already came in from the other side. Okay. And what you do is you call EPOL wait. The beauty of EPOL wait is you can actually get a timer inside. You can choose to wait for, I say, 3 seconds. And then if there is nothing, you just move on to do your own thing. And that's what Node does. Node is smart enough to say, hey, if there is actually a timer in the other phase, I am going to EPOL for that elapsed time. It's a very clever approach to do asynchronous non-blocking I/O. So I'm gonna wait. If there are data, I'm gonna get it. If there isn't any file descriptor or any connections that are ready, I'm just quitting right there and then, and I'm gonna move to the next phase, right? So that's just watch out for blocking here, essentially. So let's move to the next one. Okay, so how does I/O work in Node? So Node is completely asynchronous, i.e., what does that mean? And we can take an example here. Like I can explain what asynchronous mean. We know what asynchronous mean, right? So here's an example. Like if I'm executing code, if I am blocked by this function, that is synchronous, right? If I'm blocked by this function, that is synchronous execution. If I am calling a function like read file and I'm immediately continuing without actually being blocked by this function, I don't need to wait for this to finish, then this is asynchronous. Why? Because it's the execution of this is not determined by my execution. They are completely out of sync, right? That's how I can understand that. This execution is not in sync with my execution here, right? But here, if I execute this, I'm blocked until this is done. If I execute this, I'm blocked until this is done. And that's basically what async really means. So it's just a quick understanding there. So yeah, Node is asynchronous in a sense that anything you do, well, it depends if the function you're calling is asynchronous. It allows you for asynchronous I/O. And this is done by this beautiful library called libuv. Okay? So network I/O is implemented a little bit differently from the file I/O. Why? Because network is easier to do in an asynchronous manner. Why? Because for the network I/O, we have different little bit of approaches or data structures in the kernel that allows us to do asynchronous I/O. EPOL, and before EPOL was something called select, right? And then we have KQ and Mac, and we have IOCP in Windows. And we have finally IOUring, which is the latest Linux implementation of how you implement asynchronous IO. Hey, I just don't want to be blocked, man. I'm gonna do an IO. I'm gonna read it from a file. I'm gonna read it from a network connection, and I don't want to be blocked as a program, as a thread, as a process. For the network IO, we're gonna use EPOL in case of Linux. This is what we're gonna talk about in this course for simplicity. Okay? But the file, how do you do asynchronous in file? There is no way except IOUring is that's the only exception, right? Which is, I think they are working towards it in Node 23, but it's not fully implemented, I think, right? And yeah, we'll talk about all of this in details, like how does Node doing an asynchronous IO with file, right? So this is not the venue for it. We'll talk about it in another lecture better, but let's focus just on IO. Okay, guys, so let's take an example. So let's do a read file, right? So here is an example where we're gonna read from a file, right? And this file is called test.txt. And if the file is completed, we're gonna execute this function that's called read file callback, which does literally just prints the data. That's all, right? And I'm gonna slow down as usual. I'm always gonna slow down the initial phase so that we feel it, right? And then at the end, right after the initial phase, I'm gonna print end. So we have a printing start. We're gonna load, of course, the file system FS library that allows us to read from files, the module. And then we're gonna do these things, and then at the end we're gonna print it. And here's the interesting thing about files. In the initial phase, right, and you're not gonna find any of this information in the doc or anywhere, right? Because this is I swear you're not gonna find it anywhere, because this is something I just spent month gathering all this information by actual reading the code of Node and actually not running the code and seeing how it works, right? So just this is real good stuff. I love it. So when we read a file, especially the asynchronous version, what happens in the initial phase right there is actually we're gonna do an open. We're opening the file, but that's it. Because think about it. How do you read a file? You really need to open it first, right? In order to check, to get the metadata, to check if it exists, right? You open it in order to read it, right? But it's all kind of abstracted away with this nice function. Abstraction is the death of us all, right? Because always causing us it hides stuff behind the scenes. So we have this. I'm opening the file, and the open file itself happens in the initial phase. But then the actual read happens on the poll phase, right? So what happens here, I open the file in the initial phase. If the file opens successfully, right, I just move on. And then the actual read will be happening after the timer phase, go to the callback, pending callback, idle, all the prepare, and then finally the poll phase, we will actually execute the read and then register the callback, of course, and then execute the callback. Capiche? That's how it's done. So this will be the output in this particular case. We're gonna do a start, end, and then we're gonna read the file, and the content is hello world. Sounds simple enough. Keep that in mind, because what does it mean if the file doesn't exist? So another example is socket connect. So I am a client. I'm gonna connect to a server. Where are we connected? This is example.com. This is the IP address, right? This is the port. So what is happening here is we're going to create the socket. The actual object is empty, so this can be done in the initial phase. There's no IO here, right here, right? No IO at all. This is the IO. The IO is always deferred to the poll phase, right? So this will happen in the poll phase. And what do we do when we connect to a TCP server? Exactly, a TCP handshake, right? So SEN, SENAC, ACK, we do that jazz, and once we have the three-way handshake, that's when we get a brand new connection and we move forward. And we're getting this output, start, end, and then we get it connected to server, blah, blah, blah. And then here's what happens. This thing will keep running. As long as there is a connection, node will not end. Can you guess why, you guys? Can you guess why? Why would, if after I create a connection, why would node just terminate? If you think about it. Like the real answer to this can be only answered if you truly understand what's going on, right? We talked about this. After a connection is created, what happens in the prepare phase? The prepare phase, that connection is being added, set up in the ePOL such that we're gonna start listening on read events. Like whatever data that's coming into this thing, we're gonna watch anything that goes into this guy, anything that's coming on incoming connection. So as long as we're calling this ePOL wait, right? After we set up the connection, and ePOL wait is called where? In the poll phase, I call, hey, is there anything? Is there anything? Is there anything? And as long as we're calling that, node has stuff to do. Node has a job. Node cannot just terminate. So how do we get it to terminate? Close the connection. It's as simple as that. If you're done with the connection, if either you as a backend or the client close the connection, node will terminate. So there's no more magic, guys, that, oh, sometimes node terminates, sometimes node doesn't terminate. Now you know. Like I had this bug the other day that node would just never close, although there is nothing to do. Then I realized there was a connection leak. Like the connection that I never closed. It just remained open. So I had a leak in my case. So the connection kept running forever. That's why node didn't close. So once I found that connection in my connection pool at that time, I just closed everything, made sure everything is closed, and node was terminated cleanly in that particular case. All right. So I thought that was interesting to share. Okay. Oh, look at that. That's exactly what my point. I just explained this actually. So why does node keep running after connect? We talked about that. As long as there is a connection going on, if there is a listening socket even, it's the same thing, right? Okay, so this is the end of the theoretical explanation. Time to do actual examples, you guys, right? Summary and demo. All right. So poll phase executes IO events and callbacks, both, right? So there is an IO event that read, ePOL wait, write, right? There's these accept, listen. These are system calls, IO. Then there is also the callbacks that are scheduled as a result of the completion of these things, right? So both of them are being executed. So there's the work itself and there's the work after the work is done. Does that make sense? So IO callbacks can be scheduled by any phase. Yes, timers. We're going to learn that there's a check phase right after this that we're going to get executed. Some IO is blocking, some IO is non-blocking, and understanding the difference is very critical here. Node will try as much as possible to do non-blocking operations. Unless you did like read file sync, which is clearly synchronous. And if it's clearly synchronous, then it's blocking, right? And finally, node tries to not block when there are other work as much as possible. It's smart about that. Well, when it can, of course. There are certain cases like even in read file, right? Another thread will be blocked technically, and we didn't come to that yet. Right? I'll push that to another lecture where we're talking about synchronous versus asynchronous. Like, what is the true difference between these two guys, right? And we'll learn that read file, in certain cases, there are two versions of it. One read file is asynchronous, i.e., yes, it is blocking, but not the main thread is not the one doing the block. It's something else that is being blocked, right? And as a result, we're not gonna suffer as a result, right? Some other thread will suffer. And if there's another thread that suffers, that's fine, right? But the execution of the callback, you gotta be careful, because that execution of the callback, that is what happens on the main thread, right? Not another threads. It's gonna become clear as we go through this. This is still the beginning of the course, right? So I'm gonna write it slowly, guys. It's gonna become clear. So yeah, let's go through a bunch of examples. So I'm gonna do a Vim here, and we're gonna do the first one. Poll. What do we have here? We have an example where we're calling fs. We're gonna print s. This is the example that we explained, and we're reading a file that supposedly it exists, and then it just simply reading the file, calling the callback, printing the data, looping, and then exit. So let's go ahead and run it. Let's see if the file exists or not, because I can't remember if I did. Yeah, see, start is doing the loop. This machine is way slower than my Mac, so it's gonna be slow. Very nice. So we have start, end, and then the read. So start is the start of the initial phase, end is the end of the initial phase, and then of course read file, callback hello world. Hello world is the content of the file. That happened after the initial phase. That proves that this is way at the end, right? Things. We can add a timer, of course, and we play things here to see where things are executed. Yeah, we have a timer here. Here's an example with a timer. Same thing, but we're adding a timer callback. Exactly the same code, but we're adding a timer callback. Let's check it out. Node 05 051. So we're doing a start, and you can see that the start of the initial phase, the end of the initial phase. Then we have timer callback. So the timer got triggered, as i.e. the timer phase. And then of course the other phases that are kind of here, we didn't do anything on them. And then we have the read file callback right at the end, right? Sweet. What else? What do we have after that? 052. Here's an interesting one. I love this stuff. It reads file name _ file name. If you require fs, then you get for free this _ file name, which is the current file being executed. I love this stuff, right? This is absolutely cool, right? So if you do read file name, you always gonna get something, right? So this particular thing, this read will be executed in the poll phase, right? Because we're actually doing a read. But this guy, if you think about it, that file doesn't exist. And what do we do in the initial phase? We open the file, and we immediately find out that, oh, the file doesn't exist. So what do? We don't need to wait for the poll phase. We know the answer right there and then. So in the initial phase, we schedule the callback right there and then, right? So let's find out what will happen in this particular case. What do you guys think the output will be? Let's do node 552. We're doing a start, end. Look at that. So we did finish the initial phase. So that answers the question. Callbacks are not executed in the initial phase, right? That just answers that question. But it is scheduled before the other guy, right? So the read file callback that failed comes before the read file that succeeds. And it's natural, right? Because that read file never happened yet. This is a read file callback that failed, and the callback has been immediately scheduled during the initial phase, and it's been put in the poll phase callback queue. And when we reach the callback, when we reach the poll phase, we immediately picked up the first callback and executed, and then immediately, oh, we have a read file, let's go ahead and read the file, right? And then we go through the magic of reading the file, of course, through the other thread pool. This is very, I found this stuff interesting, you guys. I really do. Right? So we can do a trace to actually show you that if you're interested. Let's do an trace. Trace -f-t, I think -o. Let's do out.text, and we're gonna trace the first one. How about that? We're gonna trace this guy, 152 poll. There you go. We're done. So now vim out.text. The end. We're looking for opens here, right? Let's find the opens. There's a bunch of opens because Node is runtime. Of course, it's gonna open tons of files and readmes and stuff like that. So let's go find the .text file. There you go. Here's an open at. Here's an open. We executed an open, right? And we immediately did not find it, so it failed. And there is another open. That's the local path file open. So this open and this open was executed both in the initial phase. Of course, the execution of the callbacks happened later. And there you go. Writing to the screen. So this callback executed before the other callback, which is the write, because this is a write to the screen, right? Because we did the read here and we failed, the open failed, and then we did a write to the screen. 17 is the screen, right? Standard output in this particular case. And we go and where's the second one? There you go. There's the second write. The second write, which actually has the content of the file, right, which we probably read somewhere above here. We did the read. Yep, there you go. That's the read. I was just looking for it. What other examples do we have here? Let's do the connect one. Fun. So this one is gonna be a connect to the server on port 80. That's example.com. And it's gonna run until basically we kill it, right? We kill node, which will basically destroy the process, which subsequently close all the file descriptors, which should send a reset to the client or the server to begin with here. Let's do this. All right, so node 05, poll 053, connect. So I've start and then start, end, and of course connected, and then we're just waiting for something, for the server to actually send us something, right? Because we didn't really send anything. This is an HTTP server, so we're supposed to send something so that the server actually send us anything back. Since we didn't send anything, it just waited for us. Let's go to the second example. Listen. Oh yeah, first let's not run it. Let's see what's going on there. 5.4, listen. Okay, this is interesting, you guys, right? Let's read this blurb that I wrote here. When passing only the port, the listener socket is created immediately in the initial phase. Guys, this is so critical. I swear, this is so critical, right? And again, you're not gonna find this stuff in the doc, unfortunately. Right? It's because it's just too detailed, right? But I love talking about this stuff because here's the thing. If you listen immediately and say just 8080, there is no IO needed, to be honest here. There's no IO needed. So we don't need to wait until the pole phase to do any IO to do the listening, right? We can just 8080 means listen on everything. That's the default. So I was gonna listen on every single address, but on port 8080. So the binding happens right there and then, immediately. What will happen here is the moment this code is executed in the initial phase, right after start, we will be able to connect to the server, even though we didn't even get this line started. We didn't even get the printing, the listening message, and we didn't get the end. And I added, like I say, a very long loop here, right? So let's play with this a little bit, right? So you will be able to connect to this even though the initial phase didn't finish, right? So it's crazy. Let me show you first. Let me show you. I'm gonna create another connection here. Just prepare it, telnet 192.168. Which port was it? Was it it was 8080, right? Okay, 8080. So let's do this. 10.7.179 8080. Okay. Of course, 8080 doesn't work here because it's not closed. It's closed. But look at that. I am going to now run it, and I know it's gonna take a long time, right? By 4, and I'm gonna connect. Look at that. We're still running, yet we're connected, and I can send stuff to it. Now, how was it that I was able to connect while the initial phase still didn't finish yet? The reason is because that code that listens, you need to see my ugly face so I can explain this to you, because I'm very passionate about this stuff, you guys. So what is happening here is that line of code that binds the port to the socket listener has been executed. The system call was sent. The kernel knows about it. That does not mean that Node does. Well, Node just said, hey, socket, create that, right? And you connected and you probably sent something, but Node ain't ready to do any of this stuff. No, you probably didn't fire any callbacks, you didn't wire any events, unless you did. But it's very interesting to, man, that loop is really slow. How much did I do? Like billion? What is this? That's still running. But yeah, what I love about this is just the order of operation is so critical here. And we're gonna show the very next example contradicts this, right? The only reason this worked before the initial phase finished is because we have everything we need in that right there and then, in the bind, because we're just binding on a port. We didn't provide an IP address. If we provided a host name or an IP address, then there is IO involved. Then there's DNS involved. Then there's like checking involved. Like, wait a minute, I need to check that this IP exists, and the check is an IO, and the DNS is a network, is UDP, which is an IO. So an IO, you cannot do IO in the initial phase. It has to be in the pole phase. Yeah, the exception is bind. Bind is not an IO, right? Binding to a socket is not an IO. It's just like, hey, I'm just like creating. It's just like wiring objects. It's not, has nothing to do with IO. Just immediately there. As long as you have all the pieces, right? You have a port and you have, say, hey, everything, listen on all addresses. If you connect to me through the Wi-Fi, I'll work. If you connect to me through the Ethernet, it'll work. If you connect through loopback, it will work. And I'm gonna kill this because it's taking so long. All right, so let's do, what's the next one? 055, I guess, right? Listen with a host. Well, let's see what's in it first so I can show you. So on the other hand, we're actually passing a loopback, right? You might say it's just, hey, it's just 127.0.0.1. Can't Node just trust it? No, Node doesn't know what you passed until runtime. So it cannot just know that, oh, just make an exception. It's 127.0.0.1. Let's bind it in the initial phase. No, it doesn't work like that. All right. I guess it can, but the developers didn't do it this way. They say, hey, you pass me a string. The only time binding happens in the initial phase is when you only pass a port. That's deterministic. A port is a port. That's it. I'm going to listen on everything. So they can right there and then listen on all the ports. I guess we can do it in stress and show you that. We'll do that in a minute. But if you pass me an address, then all bets are off. And I have no idea what you passed. I need to check. I need to DNS it. I need to resolve it. Right? And that's just a string. So there is a function that needs to be called to verify what this is. And that is an IO. Right? If you pass it the host name, it needs to do a DNS to get the IP address, because this is a string. This is not an IP address, right? Node still has work to convert this into an actual octet, which is an IP address, in order to actually listen on just the 127.0.0.1, right? And of course, now that I bind it to 127.0.0.1, I cannot connect from the outside anyway, so that's dumb. So maybe I will do SSH, another SSH session. Yeah, let's do another SSH session. Yeah, telnet 127.0.0.1. What port was it? What port was it again? 8080, same thing. Of course, doesn't exist, but let's do this. Node 05, 055. Listen, and now connect. Nope. Nope, it doesn't work. You cannot connect. Why? Because nothing happened in the initial phase. The listening, the binding was delayed to the poll phase because we do not have everything we need in the initial phase, you guys. Okay? And if you don't believe me, because why would you? Let's change this mad number to slightly predictable number. And let's run it. Oh, someone is listening? Oh, really? This port? I probably have something else now listening on this port. So watch out for this, by the way. You might get the same error. So just change the port. You might have another server listening on 8080. How about let's do 4000? Turns out, did they change this? I swear this worked. Because I had to change my version of Node at some point, and I swear this they might change it. So this might be port IP, not IP port. So let's try this. Maybe this will work. Yeah, has to be port IP. I'll push this change. But now, of course, not 8080, it's 4000. Connect successfully. Okay, so that's the last one. Let's do an strace, so just so I can show you. And strace -t-f-o out.text. And let's do node 05055. Let's do listen without host. Okay, let's run it. It's listening, and then kill it. And I'm gonna run out H for the one with the host, and then we're gonna compare the two, huh? How about that? Sweet. So let's go to the text and let's find just listen. The listen. There you go. This is the bind. That's the most important function to this call. All right. We're binding to 8080. And essentially we're binding on all IP addresses, right? Anything all IP addresses are being bound to. That's the difference here. And here's something I'm not 100% sure. Seems like we're binding on the IPv6, all IPv6, but when we bind on all IPv6, does that mean we bind on the IPv4 as well? Because I don't see any IPv4s here. Something I might need to research. But that's interesting. I just found it interesting. Usually because the colon is the all for IPv6, right? And hopefully I wasn't breaking. I wasn't covering anything here with my face. But yeah, it's just interesting. Let's go sudo out h.text and then find listen. And clearly there is an address being passed here. Now you know which address to pass, right? 127001 in this particular case. And you know the family, and then it has been verified. Okay, so there's a very big difference between that bind and this bind. Okay. All right, guys. That's the end of the poll lecture. It was a long lecture that was filled with stuff. Just keep it in the back of your head. Don't worry about memorizing any of this stuff. It's just, there's just so much. There's just so much when it comes to I/O and the poll phase. And this is the most important phase, really, in my opinion, because there's just so much happening. And we will keep referring. I spent a lot of time in this particular lecture, and I know it's long, but we will keep referring to this phase over and over and over again as we go through this course. So keep it in mind. If there is like a piece of information that you see is confusing, just ask in the Q&A. We'll get to it, and we'll try to explore it. But just give some time as we go through the lectures. There are some lectures that will reinforce some missing information for you, like what is epoll. I know that you have a lot of questions about that. What is asynchronous versus synchronous? What does that mean, right? Although this, every programmer should know the difference, but it's not always clear what these two things mean, especially in as low level as we go here in this particular case. So yeah, keep that in mind, right? And yeah, gotta see you in the next one.